Good afternoon, everyone. It's a beautiful sunny day in California. This is Henry with A7 Tutoring with another science lesson today. Today we will start our discussion of levers with a discussion of torque and how to calculate it and what it means. All right, so let's head over to our handy dandy whiteboard. Torque is equal to the cross product of applied force and the lever arm. So remember from basic math, probably you might have seen this in calculus, that the cross product of two vectors, if you have vectors a and b, cross product of two vectors. Let's say we have vector a and vector b with an angle theta in between them. The cross product of vectors a and b is the magnitude of a times the magnitude of b times the sine of the angle between vectors a and b. And this is the smaller angle between a and b because you could go the long way around and you would get a much larger angle like this. But that's not what we use. We use the small angle between them. And remember, a cross b, use the right-hand rule, and it is pointing in a direction. But we're discussing mainly the magnitude today. So how does this apply? Well, let's say you have a bolt and you want to use a wrench. Oops. So you want to use a wrench. Hold on. Right here. Okay, this is not the best drawing of a wrench, I admit. Okay. So suppose you apply the force this way. And the lever arm is here. If these are perpendicular, the angle theta is 90 degrees. Well, sine theta is merely 1. So then that would just be the force times the lever arm, multiply the magnitudes. But if you had to apply the force at an angle, maybe it's a tight squeeze in the engine compartment where you're trying to tighten this bolt, and maybe you apply the force at a bit of an angle, right? And this angle theta. So now the torque in this case will be magnitude of the force times the magnitude of the lever arm, the length, times sine theta. And obviously this would be smaller than if you were applying the force at exactly a perpendicular angle to the lever arm. So that torque is going to, the way you're applying torque, it's going to make the bolt spin counterclockwise, like this. Okay. So how does this apply to a lever and fulcrum? Well, let's say you have a force going this way. Use your lever arm. This lever arm is very long, so the force times this long lever arm will give you a lot of torque about this point. Even if you apply a very heavy weight this way against it, because this lever arm is so short, I'll call this LW for weight, FW for weight that we place on the lever. Because LW is so short, the torque produced by these two, the force and the lever arm, the weight that's being lifted, is small enough that a small force on the end of this long lever arm on the left can apply enough torque to lift the object on the right hand of this plank, the lever. And that's how levers work. Because you have a long lever arm over here where you apply your own force, and maybe a small force, you can lift a much larger weight on the short end of the lever because that lever arm is much shorter, so the counter torque is balanced by a much larger torque caused by these two factors over here. And that is how a lever provides you mechanical advantage to lift heavy objects. The longer your lever arm is that you are applying your force to, the heavier the weight you can lift on the short end of the opposite lever arm on the opposite side of the fulcrum. I think there was a famous scientist, I can't recall who it was, maybe Aristotle or Socrates, I don't recall, but he once boasted that if he had a fulcrum and a place to stand and a lever long enough, he could lift the entire Earth. Well, that's a bit of an exaggeration because he would need a really long lever arm to counteract the weight of the Earth. But that does illustrate that by balancing torque and using a very long lever arm with a minimum force that you apply, you can use a small force to lift a very large, heavy object. And that's how torque and levers work. This has been a short physics lesson in torque and how it applies to levers. If you'd like to learn more, I am available for hire as a private tutor. The first 1-hour lesson is free for all new students. Try before you buy. You take no financial risk. The burden of proof is entirely on me to demonstrate outstanding service in helping you succeed. And as a bonus for watching all the way to the end of today's lesson, when you contact me, please mention the code FREEBOOK. And at our first lesson, I will give you a free copy of my book, Smart Suggestions for Student Success. I wrote this book in an effort to help students, and particularly high school and college students, to succeed in school, work, and life. Thanks for watching. Have a good day.